Now we will be finishing up with lesson 2-5 in the last section. We're going to be looking at different formulas and we are going to be solving them for their indicated variable. So I'm going to write all of these on a scratch piece of paper so you can watch the math that follows. But I'm going to come back and I'm going to write my answers on the actual work page. So we're going to start with our distance formula. It says that distance distance is D equals RT, where D is the distance, R is the rate, and T is the time. And it asks us to solve for R. So I want to isolate my R. Well, the R term is already isolated because there was nothing else in addition or subtraction from the R term. So now all we have to do is divide by T to get the R by itself or to isolate it. So we are going to divide T. We're going to use the division property of the equality on both sides here. And we're going to say D over T equals R. Then what we would do is we would use the symmetric property. R equals D divided by T. That would be my final answer here. R equals D divided by T. So distance divided by time. Let's take a look at the pressure equation. Pressure equation says P equals F over A, where P is the pressure, F is the force, and A is the area. And it asks us to solve for F. Okay? So we want to isolate the term. Well, the F term is isolated already because there's nothing else being added or subtracted from the term that involves the F. All we have to do is isolate the variable now. So, how do I get F by itself? Well, right now F is being divided by A. So, in most cases, when we try to undo division, we would multiply by our denominator. So we're going to multiply by A on both sides of my equation. This leaves me with F by itself on the right-hand side and A times P on the left-hand side. Don't forget to change or keep your variables the same. So I can't suddenly have a big A and now make it a small a. So make sure you keep your sizes the same. They are case sensitive, I would say. Now we're going to use the symmetric property to put the F in the left-hand side. So this is going to say F equals big A, little p. F, the force, equals the area times the pressure. Kinetic energy. All right, the kinetic energy equation says K equals 1/2 mv squared. It says K represents my kinetic energy, M represents the mass, and V represents the velocity. And it asked us to solve for M. So we are going to isolate the M term. Well, it's already isolated because all of the rest of this is being multiplied to the M. So we would need to do some division here. So I'm going to start by dividing by V squared. Okay. If I divide this side by V squared, I also have to divide this side by V squared. So I have K divided by V squared equals 1/2 M. Now, I need to isolate the M. I've got 1/2 M. Well, 1/2 is being multiplied to the M, so I could divide by 1/2. Well, let me ask you on a side note, if I have 1 divided by 1/2, can anybody recall how to get rid of this fraction in the denominator? Because we don't really like that. We don't like dividing by a fraction. In math in your earlier years, you've probably seen something like this. We're going to change this first fraction, well, this first or the numerator to a fraction. So I'm going to put 1/1. We're going to multiply by our reciprocal. So I got 1/2. This is now going to become 2/1. So I got 1 times 2, which is 2. 1 times 1, which is 1. Or this would be simply written as 2. Okay? So when we do this division of 1/2 here, this is actually going to make it 2k over v squared equals m. Now we're going to use the symmetric property. So mass equals 2 times our kinetic energy over our velocity squared. M equals 2k over velocity squared. The fourth one, gravitational energy. That equation says U equals mgh, where U is my gravitational energy, m is the mass, g is the acceleration due to gravity, and h is the height of the object. And we are solving for h. So my term is isolated, but my variable is not isolated. So I need to isolate my variable. Well, right now, m, g, and h are all being multiplied together. So if I want to get the h by itself, we're going to use the division property of equality. And instead of doing this in a two-step, I'm actually going to do this in one step. I'm going to divide by both m and g. But remember, what we do to one side, we have to do to the other. So my m's cancel out. My g's simplify to 1. So I have u over mg equals h. Or height equals the gravitational, what was that? The gravitational energy over the mass times the acceleration due to gravity. There we go. This is one that's not as common, so that's why I had to go back and look at all my variable information. So H equals U over mg. Lastly, we're going to do the Boyle's law. Boyle's law says P1 V1 equals P2 V2, where P1 and V1 are the initial pressure and volume of the gas, And P2 and V2 are the final pressure and volume of the gas when the temperature is kept constant. And it asks us to solve for V2. So I've got the V2 term isolated, but I do not have the V2 variable isolated. So I have P2 being multiplied to V2. So to simplify and do your inverse of that, we're going to use the division property of equality here. And I'm going to divide both sides by P2. Now remember, just because these are both P's, these are not the same variable because they do not have the same subscript. So this is going to be the initial pressure and volume of gas divided by the final pressure of the gas equal to the final volume of the gas. Now, again, we don't like the V2 to be on the right-hand side, so we want to use the symmetric property. So I'm going to put P1, V1 divided by P2. So final volume equals initial pressure times initial volume divided by final pressure. On to your final debriefing.